things here. So hopefully those of you that who are here in person today are on the list for Monday's classes. Let's see where I've got so many things open. I will be updating this hopefully before Wednesday. If you don't see an announcement or anything by Wednesday, the people who should show up Wednesday are on the Wednesday list. I was looking at the results from the quiz, and so not a lot of people said they didn't want to attend in person, even though we're missing, by my count, at least 5 people today who would be on the list. So my goal, I've already got emails out there, is to move us, I think, down to the first floor. I don't know if I mentioned this last Friday or not. I think we'll probably be in 136 or 138. I don't know for sure yet. It has a little bit higher capacity. That based off the responses, basically you could meet every other class as opposed to just once every 3 classes. So I'm working on, I've got the list kind of dwindled down based off the responses on Canvas, and then hopefully we can get in that bigger room to where I can basically have 2 groups and you can just kind of show up every other class period. So some weeks you'll get to show up twice, other weeks you'd only be able to show up once. Right? Look for an announcement on Canvas. Like I said, hopefully today I get a response. If not, tomorrow I'll be badging people in person. So that should be up sometime tomorrow about what the exact new room number should be. Like I said, I think it'll be 136 or 138. And then kind of the 2 groups moving forward that we can kind of alternate. Okay? All right. What should you have done before class today? 2 things. I already mentioned one. You should have done the survey. Yeah, chapter 2, Learn Smart, right? So after class today, I'll post another Learn Smart for the next kind of chapter. I want you to read it by the end of the week. So end of the day, Friday, right? We might start covering some of the material, maybe even next class, but definitely on Friday. And then definitely next week, we'll be diving deeper into it. So kind of have another Learn Smart this week, and then I'll be posting an online quiz after today's class as well. That'll be a couple questions that look like some of the stuff we did today, or referencing some of the stuff that we'll do today. So just as a reminder, and if you had worked along with me and saved it, I kind of have this car color data set that we kind of created and talked about how we can use that count if function to get this frequency distribution, right? And even relative frequencies. So the other data set we're working with is this cause of death data. So we had all these different causes of death and the frequency of people who died from each type, right? We could turn those into percent frequencies. If we remember how we did that, we just took the frequency for that category, divided it by the total number of observations, and then multiplied by 100 to get it to be a percent. Okay? So that's kind of where we left off. And we'll kind of use these 2 data sets as references. I'm moving through the next material. So, I created a blank slide because I wanted to show you. So we've got these different causes of death, and we have their frequencies, right? So the way that I could visually depict this frequency distribution will be something like this. And I'll typically use the board moving forward. Days where I know that we're not going to do a ton of board work, more Excel, I might just kind of have an empty slide so I can use this zoom annotate kind of tool. But in the future, I'm going to grab one of these desks and kind of be posted up over here. But for today, we don't need to do that. So to create this visual depiction of my frequency distribution, I'll take that first cause of death, put it down here on my x-axis. On my y-axis, I can think about what I'm going to have here is kind of the frequency. Whoops, not enter. So I'm going to look at heart disease, and I'm going to draw a rectangle, basically, all the way up to whatever the number of deaths that came from heart disease was, which I think was roughly 5.5 million. Move this over a little bit. Right, so the bar goes up to whatever the frequency was for that specific response for that variable. So we're looking at the variable cause of death. The number of observations we see that the cause of death was heart disease, we count them up, get that frequency of 5.5 million. That's where that bar goes up to. The next one, we're going to put over here. I think it says malignant neoplasms, but we kind of said this is just kind of referencing cancer. And then I'll take the frequency for that cause of death. I believe if we looked at that one, it was something like 4.4 million, right? And then kind of draw the bar for that cause of death or that response to that variable up to that point. Okay? I then continue to do this for every single one of the different causes of death. By the time I'm done, I have something that looks like this, right? A little bit nicer and neater, but right, I've got my frequency, the number of deaths that come from heart disease, 5.5, notice it's in the millions, cancer, 4.4, so on and so forth, okay? So the reason why we like to do these kind of visual depictions is because right away it stands out to you that two of these causes of death are killing way more people than the others, right? So if I'm arguing, you know, I'm trying to get funding, and I'm saying, look, if this is impacting a high number of people, a much larger number than the rest of these deaths, this would be a nice visual depiction to convince somebody of that. Okay. You know, if instead of using those frequencies, let's say I wanted to create a bar or a kind of column chart using the same cause of death, but looking at the percent relative frequencies. I could do the exact same thing, and instead of on the y-axis plotting, you know, 5.5 million, I could plot 32%, right? Now, the only thing that should change if I do that is my y-axis. So if I do that, notice here's my percent relative frequencies. This graph looks exactly the same as when I used frequencies on my y-axis. So why is that the case? Well, I'm dividing everything by the same number. I'm dividing by the total number of observations to go from frequencies to relative frequencies. Then to go from relative frequencies to percent relative frequencies, I'm multiplying each one by 100. Well, if I multiply and divide by the same number, it doesn't change the relative size of those values. So I always say, you know, think about this way, right? 2 is half of 4. If I divide both those numbers by 2, well, now 1 is half of 2. Or if I multiply by the same number, right? 5 is half of 10. Multiply those both by 2, 10 is half of 20, right? So if I'm multiplying and dividing by the same number, the relative size or the ratio of those numbers doesn't change, okay? So it doesn't matter if we use frequencies or percent frequencies, we're gonna have the same visual looking graph, but the y-axis now just gives a little bit different of information, right? Maybe here I'm really trying to shock someone with how many people are dying, and here I'm trying to say, well, look, give me the money for this research because over a third of people are dying from heart disease, right? 33%, okay? So it just kind of depends on what you're trying to convey to the person that you're displaying the data to, but the process is really the same. It's just different values in that y-axis, okay? Also, I don't know if you guys heard me talking to some people in class. If the Zoom at any point sounds robotic or anything, make sure you let me know so I can fix it right away. All right, what did I want to do here? I wanted to go back. Oh, no, I want to mention this before I go back. So you can also do a pie chart. I'm sure you guys have seen these maybe in like, I don't know, 8th grade, 9th grade science or something. Right, the larger the slice of the pie, the higher the number of observations that fit those different type of categories or those responses. Okay? So let's go back to that car data set that I kind of created last class. And we had calculated, I guess we could label this a little bit better. We had calculated the frequencies, right? The number of red cars, the number of blue cars in this data set, so on and so forth. If I wanted to turn this into a graph, all I have to do in Excel, I'm going to highlight those different responses for the variable. I'm going to highlight their frequencies. Go to Insert. There's all these different charts. I just want a column chart. You can do 2D. You can get fancy and do 3D, right? Now this gives you a quick visual that most of the cars in this data set, or this lot, wherever we're looking at, are blue or black, okay? And not quite as many kind of these other colors, right? And that's a quick, you can get that. You don't have to look at the data set. You know, when I look at the data set here, maybe I could figure that out. But if I had 2,000 cars, it'd be a lot harder for me to figure that out, right? But based off what we did last class and knowing now how to insert this chart, I could do this with 2,000 observations just as easily. Okay? Any questions on that? Now, what if I had accidentally just looked at my frequencies, highlighted them, and then inserted a chart here? Well, now my x-axis labels are numbers, and that is like no, whoops. What did I do there? I want to move this, there we go. Right, I don't know what colors these numbers represent. So a nice kind of way if you forgot to do that, and we'll do this on some other graphs that we'll probably talk about Wednesday. I don't think we'll get there today. Left click on these numbers, see how it kind of puts a box around them. Now we right click, go to select data. So notice the axis, the horizontal axis labels right now are just these numbers. If I click on this edit button, I can then select the data that I want to use as these labels. So once I select those labels, I hit OK. Now it doesn't matter, but if I forgot to select them, I can add them in after the fact. Now the easiest way is always just select the labels and the frequencies at the same time. But sometimes, I don't know, maybe, well, they shouldn't be because you're creating it, but maybe they're somewhere like down here, right? It's not as easy to select them at the same time, or I don't know, but generally you should be putting them right next to each other, and it's just as easy to highlight them both at the same time and then insert your graph. Any questions on that before we keep moving? Let's see the chat. Okay with that? All right. That shouldn't be too bad. We can do the same thing with the relative frequencies. One little trick, I guess, here we'll delete this, is if I have columns that aren't next to each other, to select both of them, I'd be highlighting, the frequencies and the relative frequencies. Simply highlight my labels, hold Control, and it might be hold Command on a Mac. Usually whenever I say something that is, or whenever I say Control, referencing something we'll do in Excel, it's usually Command on a Mac. And then holding that, select my relative frequencies. Now I can go to insert a column chart, and I can get my relative frequencies as my y-axis. Okay? Any questions on that before we keep moving? I don't think that should be too bad. Kind of starting class off with some things we talked about last class. And now we'll move into quantitative variables as opposed to qualitative. Right? So with those qualitative variables, I was counting up the number of blue cars, right, getting the frequency, counting the number of yellow cars, getting the frequency. So what if instead of a qualitative variable, I had a discrete variable, right? So let's say I ask, a survey question, the number of kids that are in the household. The possible responses I could see would be 0, 1, 2, 3, 4, I don't know, hopefully stops at 10 or something, right? But it's the same process to come up with a frequency distribution for that discrete variable as it was for the qualitative variable, because all I have to do is go through that data set, count the number of responses that said there were 0 kids in the household, write that frequency down. Count the number of responses that said there was 1 child in the household, write that number down. Go through every single possible response. Once I'm done, I now have a frequency distribution that I could very easily in Excel kind of just highlight and insert a graph on, right? Or insert one of those column charts. Okay? So with a discrete variable, it's the exact same process that we just worked through. You can kind of imagine, where were we here? So remember, just a little bit of a reminder, we were using that count if function to say, if the variable is equal to the word red. Well, the only difference would be, instead of red, I'd have, or I guess the first response was 0 kids in the household, and then 1 kid, right? But we would still use the count if function. You could still do it exactly the same. Instead of saying, is it equal to red, now you're just saying, is it equal to this one specific number, right? So nothing really changes, and then this won't work here because we don't have any zeros, but, and I can show you it would work. So if I put a 0 in here, notice it counts that there's 1 0, right? So it works exactly the same way. Okay? But what if I've got continuous variable, right? Well, there is a problem, right? Because if I'm trying to count income, for example, the very first value I'd be saying is how many people had $0 of income last year? Write that frequency down. Then go through my data set. How many people earned 1 cent, right? 1 penny last year? Write that number down. How many people made 2 pennies? I'd have to go through every single possible response I could see for that income variable. Well, that's going to be absurd. I'm going to have so many different horizontal axes, categories. I can't depict it, right? So when we have continuous data like income, what we're going to do is create kind of these bins or these classes, right? So that's kind of those two terms are interchangeable, right? So once I have these bins, I'm then going to count the number of observations that fall in those bins. So my example with income might be something like how many people make between 0 and $100,000. If the salary, and I go through the data set, if the salary is between 0 and 100,000, I count it, write that frequency down. So now that bin, 0 to $100,000, will have a frequency. Then the next bin would be something like, do they make more than $100,000 up to $200,000? Go through the data set, count the number of observations that meets that criteria, write that frequency down. Kind of go through and do that until I've counted every single person in my data set. Now I've got these bins, I've got these frequencies. it's exactly the same as graphing it as we did with qualitative variables once we have those frequencies. Okay? And we'll walk through an example in Excel today how we would do that. You know, to do it by hand, if I had, say, a 2,000 person data set, is not going to be something we want to do. Okay? So if we have this continuous data, right, and we create these bins or these classes and then get our frequencies, once we put those frequencies into a bar chart, we call this as a histogram, right? So it's really just terminology. It's the same thing that we did before. We just call it a histogram because it references the fact that this isn't like one specific response. It's a bunch of different responses that fit this category, right? You could see 20,000, 30,329, any number, but as long as it was between 0 and 100,000, it was counted in this category, right? That's all that a histogram kind of references, that we started out with a continuous variable, and to graph it, we had to create these bins, okay? Or these categories, think about it that way. Generally, the number of bins that we choose, or the number of classes, is going to be somewhere between 5 and 20. Right? If I just create 2 bins, like let's say I say, how many people make between, I don't know, $0 and $500,000, and how many people make 500,000 or more? Well, that's not a very interesting graph, right? I'm going to see a majority of people between 0 and 500,000, and a very small number above that. Okay. Now, if I choose something like 30 or 50 bins, well, now I've got the same problem I did before when it was continuous. It's just that I get this super long graph and the visual doesn't really help me much. Okay? So generally we try to keep it somewhere between 5 and 20. If we have like a homework question or assignment, this will be kind of specified for you. I'm not going to make you choose it. In practice, we would kind of, whoever's working with the data would choose it, right? Kind of up to them how they want to display the data. So there's no real set rule, but the equation that we'll use once we've selected the number of bins we want, there's an equation that gives us kind of what the bin length should be, okay? And the equation is you take the maximum value in your data set, you subtract the minimum value you see in the data set, and divide by the number of bins. I can explain kind of the intuition behind this, right? So let's say I have a data set and maybe it's like test scores. So I can only see between 0 and 100, right? And I want to break this up into 10 bins. Well, if I could see scores range from 0 to 100, and I want 10 bins, what should the length of every bin be? 10, right? You took the range of data, 0 to 100, divided by the number of bins, 10, 100 divided by 10 gives you 10 bins with length of 10. Right? Now, a lot of times it's not as easy as that, right? 0 and 100, kind of nice, easy numbers to work with. But this is the equation that we'll use, okay? We can do some, this isn't a hard and fast rule that we have to use exactly whatever that bin length is. And so if we play around with what the bin length is, and I'll show you some examples in Excel why we might want to do that, we have to make sure that our bins are mutually exclusive. So what that means is an observation can't be in more than one of these bins. So the main way that this is a problem, so an obvious way would be if I counted the number of observations between 0 and 100,000, and then the next bin was, did they make between 50 and 150,000? Well, there's a bunch of salaries, like 75,000 would fit both of those, right? Now, the other place where, so that's kind of obvious, we usually don't make that mistake. But if I said, I want to count the number of salaries between 0 and 100,000, and then I want to count the number between 100 and 200,000, we have to be careful with that equality, right? Because if I made exactly $100,000, I would count in both of those bins. So we have to say something like, did they make between 0 up to and equal to $100,000? And then the next one we would say, did they make more than 100,000, right? Or greater than $100,000. So make sure that equality wouldn't be kind of on both of those bins so that that could be double counted. That's all that kind of mutually exclusive means. They have to be exhaustive. So the income example is a good one to display how this can go wrong. So let's say I do bins. They're all mutually exclusive. And I go from 0 and the very last bin stops at $1 million. Well, what's the problem? There's some crazy people making way more than $1 million, right, that aren't going to get counted. So we have to make sure that our bins would include any possible observation we could see for this variable. Okay? Now, a way we get around this a lot of the times is like with that income one. Maybe I do bins up to $1 million, and then I have a final bin that just says, count the number of people who make more than $1 million, right? It's like left open-ended, and that kind of can solve that issue. Generally, we try to keep classes or bins the same length. So when I'm saying things like, 0 to 50,000, 50 to 100, 100 to 150, right? I'm trying to keep those bin lengths the same. These are just some guidelines. We can break them if we think that it makes sense, like creating those catch-all categories at the end. They wouldn't have the same length, the bin length, but it makes sense in the context of that variable. Okay? Any questions on that before we keep kind of pushing forward here? Get to some Excel where we can kind of see this in practice. So we'll walk through how we use that bin length equation first, and then we'll hop into Excel. So you might see a question that looks very similar like to this on today's online quiz. Okay? So I'll post that online quiz after when I get back to my office. I have it ready to go. And it'll be a different example, but same sort of idea. So let's say we're looking at SAT scores. We've got a bunch of different Indiana schools, and I want 9 bins. So I want to know how many schools have really low SAT scores, how many have higher ones. I look through the data set and I see the school with the lowest average SAT score is a 352, and the school with the highest is 648. I think this was just on like the math portion or something. So I've got the maximum in my data set, I've got the minimum in my data set, and I have the number of bins that I want. So if I go back here, so I take the difference between the maximum and the minimum, and then I divide by the number of bins. So here I just take 648, subtract 352, and then divide by the number of bins 9. So if I do that, I get approximately 32.88 repeated. Well, that's fine. That is like the ideal bin length in terms of the mathematics, but visually this is not optimal, right? If I have to start showing how many schools are between 352 and 384.888 and then add another 32.8, I start to get these just real messy looking numbers, right? So a lot of the times what we'll do is just push up and use the next highest integer. So 32.88, I'll just use 33. It's a lot cleaner, it's a lot easier to kind of see the cutoffs there. And as long as I push this up to the next integer, when I say push, not just round, because even if this was 32.1, I'd want to push it up to that next integer of 33. I'll usually call that ceiling, because once we use, eventually in Excel, we'll use this idea, and the function is called ceiling. So right, you ceiling it up to the next integer, or you push it up to the next integer, even if it was 32.1 here. Now, the reason we do that is because if I round down, my last bin will actually stop just short of whatever the maximum value is, and then it wouldn't get counted. So I want to make sure we always kind of use the next highest integer when we're calculating this. Now, in some examples, we don't have to worry about that at all. Like if I was dealing with really low dollar amounts, it might make sense for me to do like $1.25 jumps. That doesn't look that bad visually. But depending on kind of the problem, we might want to kind of change this a little bit. The equation gives us a good starting point though. Okay? Any questions on that? Shouldn't be too bad. I think it's pretty easy. So I've got some slides here with just some kind of reminders of how we do some stuff in Excel. We're going to work through all of this today in class. These are just, you kind of go back as you're taking notes. These might, I don't know, if you look at the notes and you can't decipher it, these slides might be helpful. The cell references right now don't make any sense. I'll update them for the file that we're going to be using. This is based off an old one, but I wanted to do something a little different, updated some of the data. So once we work through everything in class, I don't think we'll completely get through it today. So after Wednesday's class, I'll update all these cell references in the slide to match exactly what we did in class. Okay. So got a bunch of stuff here, but let's look at that COVID data blank file. So that's up there on Canvas, under Files, under the in-class data folder. If you open it up like last week and you still have it open, you're trying to go off that, I re-uploaded this morning, changed a couple things that I thought were a little bit more interesting for us to work through in class today. So if you pull it open, you've got a bunch of different worksheets down here. The one that we're going to use today is the state level data. Okay? So click on that state level data sheet, and it's all the COVID, I came up with this weekend, it's all the COVID cases and deaths in each state, and I think Puerto Rico's in here, and I think DC might be in here. Some other non-state, Puerto Rico, and it doesn't matter. I think it's DC, it's somewhere. But this is of last Friday, the cases and deaths in those essentially states, okay? So no one yelled at me yet, but if I ever keep it just at 100%, always remind me to blow it up a little bit more so we can see it easier, okay? So I've already created the labels for our bins because I cheated and kind of knew where I was going ahead of time and didn't want to waste class time to like type this out. So once we get to that point, I'll mention, you know, kind of some different things we could have done. I just wanted some labels here once we eventually are able to graph these frequencies into a histogram, okay? So the very first thing we'll do is we got to figure out what our bin lengths are going to be. In order to figure out what our bin length or our bin size is, we need to know the number of bins we want. So I'm just going to say, for the sake of this example, let's do 6, okay? So I want 6 bins. Now in order to calculate the bin length, I'm going to have to find the maximum and the minimum, and then take the difference between those and divide by that number of bins, divide by 6. So to get the maximum, I want Excel to find it for me. So I'm going to tell it, here's an equal sign. I want you to use a built-in function, and that built-in function is the max function. Basically, whatever numbers I select, this function will tell me the highest number or the maximum number. So I can use my mouse and drag all the way down and select all this data, right? And that'll be fine. Or I can use that shortcut I think I mentioned last class, which is if I select on that very first data point, I can hit Control-Shift, hold Control-Shift, and hit the down arrow, and it goes all the way down to the last observation. If you're on a Mac, instead of Control-Shift, anytime I say Control, we should think Command, so hold Command-Shift and hit the down arrow for that shortcut. Now, this data set's not huge, but if I had a much larger data set, maybe I had like cases by county. That data set does exist. You can actually go pull it off the CDC's website. That's going to be really useful, right? Instead of having to drag it through every single county. If I then want to find the minimum, we can kind of imagine if the maximum function is max, the minimum function is min. I select that range of data again. Once again, Control-Shift, hold Control-Shift, or hold Command-Shift on a Mac, hit the down arrow. It'll fill in kind of that cell reference. And now we've got the maximum and the minimum and the number of bins we want, okay? So from here, it's just a matter of getting, where is it? This bin length equation or bin size equation entered into Excel. So here we want math to do Excel. We want Excel to do some math for us. So we start with an equal sign. We want it to take, instead of having to type these numbers into a calculator, all I have to do is click on them. I want to take the maximum minus, and here I can't click on this one because my Excel is doing something funky that I need to change the setting on, but I know it's cell what, I2. All right, so I want to subtract the minimum and then divide by the number of bins. So why is this not going to be correct? Yeah, right, order of operations. So just like a calculator, if you're doing this by hand, order of operations applies in Excel. So what I really want to do first is take the difference between the maximum and the minimum and then divide that by the number of bins, right? So I'll put parentheses around that. Parentheses will be your friend in Excel to kind of make sure your order of operations is working correctly. So now I get this kind of bin size. Well, it's kind of messy, right? It's got some decimals, I don't know, it's kind of a weird cutoff. So what I decided, just to make the graph look a little bit cleaner and the numbers look a little bit cleaner, I just decided instead of pushing this up to the next integer, I'm going to just actually push it up quite a bit, up to the next 25,000, right? The next 25,000 denominator. Not denominator, nominator, okay? So that's the bin kind of length we're going to use, and that's what I use to create these labels. Also, I forgot to change this. I made a typo on that label, so we'll change that label so that it's correct. All right, so we've got my bin length that I want to use. What I'm going to go through and do, I've got these labels, but in order to calculate the frequency, it's going to help me out a lot to have the minimum and the maximum of each bin. Okay? So instead of like going from the income going from 0 to 100,000, 100 to 200, we're going to be going from 0 to 525,000, 525 to 1,050,000, so on and so forth. Now, we're going to say the min and the maximum of each bin are whatever those cutoff points are between the bins, right? So 525,000. But we do know eventually we're going to have to be very careful about where we put the equalities, right? Because if I had exactly 525,000 cases, I might get counted in both these categories the way that we currently have it set up. So we'll eventually get to how we deal with that. So the first thing we're going to do is that very first bin starts at 0. So the minimum of that bin is 0. The maximum of that bin is 525,000. So if I see a total number of cases for a state that's between 0 and 525,000, up to and including 525,000, it gets counted as belonging to this bin. The next bin, I would say, if it's greater than 525,000, up to or equal to 1,050,000, then it gets counted in that bin's frequency. So I want to create this minimum and maximum for each bin, and I want to find the frequency. Okay. So I think we'll do this a little bit different order than I did it last class. So we'll see, hopefully this maybe helps a little bit. So we've got this first bin. What we're going to do is say, okay, look, we use this count if function when we're dealing with qualitative or discrete variables. But the thing was we just need to know, was it equal to that one number? Now, what I really want to know is, I only want to count the observation here if it's greater than 0 greater than 0 and less than or equal to 525,000. So I have, two things that I'm checking, right? Is it above this value and is it below or equal to this value? So we're not going to have to not be able to use a count if, but instead use a count ifs, right? Real creative with the naming there. So the first thing it wants to know is, well, what data am I looking through, right? What's the range? So we'll kind of click here, Control Shift or Command Shift on a Mac, select all of our data, move this out of the way so you can see it. So that's my range of data. Right? I'll then put a comma. The next thing it wants, well, what is the first criteria you want to check? Well, the first thing I said is it greater than 0, right? Now, for the first bin, that seems obvious, but for the next couple, right, we'll want to know here, is it greater than 1,050,000, right? So we're going to use this eventually to kind of match, keep the same format for all the following bins. So we say, is it greater than, just like last class, if we use an equality or we use a greater than or less than, we have to put it in quotation marks. So greater than sign, use the and sign, right, and say, is it greater than the lowest value of that bin, right? Greater than 0. That's the first thing I want to check. The next thing, so I put a comma. For whatever reason, and I know the reason. In this example, it doesn't make sense, but we can use the count ifs function to do other things. We now want to tell, okay, check to see if that holds, but then go back through the data again and make sure that it's less than or equal to the maximum of that bin. So the third thing we need to tell this function is we actually just have to highlight that range of data again, right? So instead of highlighting it, especially if it's a larger data set, usually what I do is I can see what the cell reference is, right? C2 through C53. So usually I actually will just type it in there instead of selecting it. And that colon means like go from C2 to C53. Now, comma, the second criteria I said, is it less than or equal to the maximum of that bin, 525,000. So you need to put it in quotation marks. Is it less than or equal to, use the and sign again, and then instead of typing in 525,000, we've got it sitting over here in a cell. Okay? Now, one thing I want to mention real quick, this less than or equal to, you type it into Excel the same way you would say it. So if I want it less than or equal to a certain value, I put the less than sign first and then the equal sign. If I want it greater than or equal to, put the greater than sign first and then the equality sign. Right? So that's actually kind of nice. I'd really screw with you if they decided to flip that, which they very easily could have. But now we have kind of this count ifs function that should go through this data set and count the observation if it's greater than 0 and if it's less than 525,000. Okay? Now you might say, why didn't you just type the values in there? It would have been a lot easier. And instead of now looking at these cell references, I have to look at, okay, what's numbers in this cell? The reason I did this is because we can actually complete the rest of this very quickly if we set it up this way. Okay? So I've got my count ifs function here, and it counts that 37 of the it's not 50 states, it's like 50 states and 2 municipalities, or I don't know, whichever you want to consider, however you want to call them, US territories. 37 of them fit in this first bin, okay? So the majority of states have less than 500,000 cases, approximately. Okay? So if I want to keep doing this for the next couple bins, notice the next bin picks up where the last bin left off, right? I mean, it wouldn't be, you know, it would be greater than 525,000, but it picks up where the last bin left off. So the minimum of this bin will just be equal to the maximum of the previous bin, and that'll always be the case if I've done it correctly, right? The next bin should pick up where the last bin left off, okay? Now, the maximum of the next bin should be what? Well, if I know my bin length, I should always just be going from where my last bin left off, or this new, you know, the minimum of my new bin, and I should just be adding whatever that bin width is, right? Okay. Now this is great because now when I copy this down, notice this one, instead of being J7, remember when I copy it down, it'll become J8, so it'll be using the maximum of the previous bin, right? It'll kind of update it accordingly. Now for the maximum of the bin, if I copy this down, instead of I8, it'll be using I9, which will be the new minimum for the next bin, so that's good. But I4 will become I5. Doesn't have anything in that cell. So what do I want to do here? I mentioned it last class. You might not remember the term, but what could I do to make sure this cell reference of I4 doesn't change when I copy this down? How close were you paying attention on Zoom?
You would anchor it with $signs.
Yeah, so someone here said it and someone in class said it, right? I use $signs in front of my column and row reference. And I'll review the shortcut here in a second for how we do that, but I just typed them in there because it was just one cell reference, pretty easy. Now when I copy this down, it'll use I9, which is the new bin's minimum, and add to it that same bin length that I want to keep using. So now when I copy these down, updates everything for me right away. And notice it'll hopefully match the labels I created. Hopefully I did the math in my head correct here. Okay? Any questions on that before we keep moving? Kind of pause here. Look at that count this function again. Okay? We're all right with everything? Especially on Excel early on. Ask questions, even if they seem simple, like it's tough. You know, I try to revert my mind to when I knew nothing about Excel, but right, it's hard to do sometimes when you do know something. So if there's something I did and I maybe forgot a word or kind of glossed over it, make sure you ask a question on it, okay? Okay? So we've got the minimum and the maximum of each bin set up now correctly. Well, that COUNTIFs function, right? For the next one, I could type it out all over again, right? For the next bin, so that I would say, is it greater than, not 0, but 525,000, right? And I just want to make sure it's greater than, because remember, this bin, I said, count it if it's equal to 525,000. So I don't want to have the equality there, so that's good. I want to keep looking through the same range of data, and I want I7 to become now I8, and I want J7 to become J8. Well, the nice thing is when I copy this down, what happens? I7 and J7 become I8 and J8. The only issue is when I copy this down, C2 through C53 will become C3 through C54, which would then be missing that very first observation. So what do I want to do to that cell reference? $signs, or freeze it. So the shortcuts that I think I mentioned last class was on a Mac, you hold Command T, you hit F4 if you have a regular computer, or if you have a laptop that decides that it wants to have a smaller interface and put an FN key on there, you hit FN, hold FN and hit F4. Okay? So on kind of PCs, hit F4, or if you have an FN key, hold FN, hit F4. If you're on a Mac, Command T. Should put those $signs automatically in there for you. Now we selected the range of data over here as well, so we have to make sure we do the same thing over there, right? But now when I copy this down, it'll keep the range of data the same. And now the next line, it would count it if it's greater than 525,000 or less than or equal to 1,050,000. And I copy it down for the rest of the bins. It'll just update that minimum and maximum for each bin. So I hit enter. And I'm not sure if I said this last time. So if I hold my left mouse button and then I drag this down, that's how I copy it down really nice and easy and nice and quick. Okay. So you can kind of see the majority of states here are what? Under 1 million, right? There's 11 between these two and 37 between these two values. And there's a few states that have really high number of cases. We, you know, in an ideal world, I would have taken more time and energy, went out and found current population data, you know, created per capita cases, and then used that. It'd be the same process once we had that new variable. Well, so we can probably guess which states here have the highest number of cases. It's probably the states that have really high populations. So California, I think the other high ones, here they are, Florida, Texas, another one over 1 million, I thought. Oh, it's way up here, Illinois. Okay. So this kind of gives us a nice frequency distribution and say, look, there's a couple states where things are kind of out of control and outrageous, but the majority of states, at least the numbers have stayed relatively low. Now, states like Rhode Island, we would expect that hopefully it's the number of cases is somewhere in that first range, right? But, you know, this is just a nice, quick, easy sample data set we can work with, forcing the data into these bins and getting this nice frequency distribution. Okay. So once we have these frequencies, it's just like what we did with qualitative variables. Highlight the labels, hold control, select the frequencies, go to insert, go to one of these column charts. Now I've got my histogram. Now I could have made these labels look a little bit nicer if I wanted to spend a little more time. I'm not trying to teach you how to create beautiful things. I'm just trying to create you how to get the statistics to the graph. You can play around with all the formatting stuff. I think here I had my, so this will look similar to your first assignment. It'll be a little bit different. What we've done in class today, a lot of that will be on that first Excel assignment. Not posting that today or anything, but we still have some stuff to work through. But you know, here's some cleaner, nicer, prettier looking labels, right? I used some greater than and less than or equal to signs to really make sure that what was put on the graph as the x-axis labels really identified what that bin category was. I got a little bit kind of lazy with this one because I wasn't concerned with too much about the visuals of the labels and more about how we actually come up with the frequencies. Okay. Any questions up to this point? We're okay with this? There's a little bit more I want to kind of do. So the first thing, I'm going to delete this just to get out of the way. If I wanted to calculate relative frequencies, what am I missing here? So to turn a frequency into a relative frequency, I need to divide by the, so I think someone said it earlier when we were talking about it, total number of observations. Well, I don't have that here, right? Now I could probably look on the row, these rows and count and say, okay, down to 53, but this first line is not an observation, so 52. But I don't want to do it that way because if my data started, say, like in cell 3, and I've got a couple thousand observations, I don't want to scroll all the way down. A nice, easy way we could do this, if we have the frequencies, how can I get the total number of observations? So every state, or state plus a couple others, should have been counted once in these bins. So if I add up the frequencies, we've said the frequencies should always add up to the total number of observations, if I did it correctly, right? If I made sure, I have the equalities on my bins right and everything. So last class, I introduced this sum function, which was basically, so equal sum, just highlight what you want to add up. So I want to add up all these frequencies. I just highlighted them, and it put the cell references in automatically, right? I just select them with my mouse, 52. Right? Now, if I didn't want to scroll all the way down, look at the row headings, another good way to check to make sure when I add up my frequencies, I'm assuming right now that that's right, that 52, that's my total number of observations. Well, if I made a mistake and like I double counted, an observation in some of these bins, I could be wrong. But a nice way to check this is we have something called a count function. So equals count, and then you just select the variable, so the range of data. So I'll select here, go Control Shift, Command Shift on a Mac, hit my down arrow. Instead of scrolling back up and closing the parenthesis, I can just hit Enter. It just counts the observation if there was anything in the cell, right? So it's going to count the number of observations for me. Sure enough, I was correct, right? It's 52. So I didn't make a mistake here, or at least an egregious mistake, right? So now that I have my total number of observations, how do I come up with my relative frequency? Well, it's just my frequency for that bin divided by the total number of observations. Now, when I copy this down, instead of K7, the next cell would use K8, or the new value for the new bin, but K13 is going to also keep updating. So I want K7 cell reference to keep updating, so I'm using the new frequency for the next bin, but I want the total number of observations cell to stay the same. So I'll freeze that or put dollar signs in front of that row and column reference, okay? Any questions on that? Shouldn't be too bad. And now we know we could copy this down. Now we've got all of our relative frequencies. I could go ahead, I could graph those in the same manner I graph the frequencies. Nothing would be different there. How would I turn these into percent relative frequencies? Simply do what?
Multiply the relative frequency by 100.
Exactly, right? I take my relative frequency and I simply multiply it by 100. I'm just having Excel do the math for me. Instead of having to round this number, type in 0.712 into my calculator, I just click on that value and Excel uses it all the way out to whatever decimal it stops at, if it ever does stop, right? And then I can copy that down. Now I've got my relative frequency for all the other bins as well. Once again, how would I graph those? Select my labels, hold Control or Command on a Mac, I think, and then go to Insert, Column Chart, which is exactly what we were doing before. Now it's just using my percent relative frequencies on the x-axis. Sorry, on the y-axis, right? Talking too fast. Okay? So what should these relative frequencies add up to? If I add up these relative frequencies, hopefully they add up to, if they represent proportions and every observation's been counted once, they should add up to 1. Yeah. And I had copied this down already, so kind of, if I had this as a sum, or sorry, I multiplied this by 100, so 1, if I add up my percent frequencies, they should add up to 100. So we can actually check that, right? Equals sum, add up my percent frequencies, hit enter, they should add up to 100. So hopefully I made no egregious mistakes here, right? Now, the reason why how we have this set up is kind of nice is, let's say my kind of initial stuff changes. Now, I rounded up here without any real rule. Let's say, I wanted the numbers to be nice here, but let's say, just for the sake so I can show you this, that, and you don't have to worry about this function because we're not going to use it anytime soon. I'm just going to use it right now so that we can kind of get a nice view of this. So let's say I just round this up to the next integer, or to the nearest integer, all right? So it should push it all the way up to 56. Why isn't it doing that? Let's do, is it 0.1? Yeah, so it's pushing it up to the next integer now. So because I've been referencing that bin length here when I was doing the min, the maximum, and then those were used in my frequency calculation, let's say 6 months from now, I go back in and I don't know, the number of cases in one state is 8 million. And the lowest number of cases in a state is maybe, I don't know, 30,000. So I have a new min and new max, right? And I could have had a new data set here. What updates my bin length, and actually this first one won't be right because I should have not just typed it in, but all these, notice, have kind of updated. Now, if I had been better and not just typed a number in here and actually used a cell reference, right, where I could have like just said it's going to be the bin length there, notice everything kind of updates. I get my new frequencies and I can, have a new graph with new data just like that, right? But it's only possible if I use the cell references. Otherwise, I have to go back through, type in every minimum and maximum again, type in every minimum and maximum value in my count ifs formula. You know, it just, as long as I use cell references, if things change, I can make those updates almost instantaneously. Okay. All right, any questions? Kind of go back to where we had that there. Any questions on that? All right, well, I'll be posting that online quiz as soon as I get back to my office. I'll get that new Learn Smart up there that's due by the end of the day on Friday, all right? The online quiz is due before the next class starts. That's always what it is. So it'll be due before Wednesday's class starts. 2 questions, real easy. I guess technically 3 questions. The one is just so you get the base points. If you have any questions, feel free to reach out. And I should be looking for look for an announcement on Canvas. I should be getting that new room hopefully for us by the end of the day today or at some point tomorrow. Okay. All right. We'll see you guys again Monday for sure, but maybe a little bit earlier if we can get the new class. And then some of you on Zoom, I'll see you guys on Wednesday.